So because it's a square root function, after we find this translation point of 3, -2, the square root of 1 is 1. The square root of 1, 2, 3, 4 is 2. There we go. And there's, hard to make it, there we go. There's our function. This one is moved to the point 1, 2. But with this one, it's going to go down because it's negative. So we go over 1, down 1, over 1, 2, 3, 4, down 2. And our square root function goes like this. This one is shifted to the point -2, -6. So -2, 1, 2, 3, 4, 5, 6. Now, because of the 2 out in front, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, but we have to double those. So we go over 1, up 2, over 1, 2, 3, 4, up 1, 2, 3, 4, over 9, let's see, 2, 3, 4, 5, 6, 7, 8, 9, up 1, 2, 3, 4, 5, 6. And there's this one. Okay, so what if we ask, where is this function equal to -4? So one way that could look is I could say, instead of h of x, I could say -4 equals 2 times the square root of x plus 2 minus 6. Now, just like before, the only way I would ever solve an equation using a graph is if I already had the graph. So I'm only going to ask you this kind if I've already asked you to do the graph and you've already talked about the domain and the range and those kind of things. So this is the only time we would ever use this as a way to solve. But to solve it, we would just come down here where y is -4. Where is the function -4? And what is the x value right there, guys? -1. So x equals -1. Now this is very similar, but it asks, where is it greater than this -4? So it's greater than that -4 from this point to forever this way. It is greater than -4. So we would say this interval from -1 to forever right. Okay, now for homework, I want you to go back and do the same thing for the first two. Alright, let's take a look at the bottom now. Let's go ahead and graph these. So we're going to shift up 3 units. This one has an inflection or a translation point at 0, 3. We're doing cubed roots, so the cubed root of 1 is 1. The cubed root of 8. How many tick marks do these have, guys? Is it 10?
Yes.
Okay. So the cubed root of 8, I can come back to get to 8. The cubed root of 8 is 2. And then the cubed root of -1 is -1. And the cubed root of -8 is -2. And that gives us our little swoosh. That is our cube root. Now this cube root's translation point moves to the point 1, 2. So that's where we'll start, 1, 2. Now because of the negative out in front, instead of going right and up, we're going to go right and down. And then we'll go over 8 and down 2. And then here we'll go back and up and back and up. And so there's our reflected cubed root. Okay, so let's do this one. We'll answer these questions for this one. Where is it equal to 0? Well, I don't even have to draw in the little line because there's a dot right there where it equals 0, isn't there? And I can see that's the point where x is 9. Okay? Now, it might help me to draw one here at 1. So where is this function less than or equal to 1? So from this point to forever that way. So that point is the point to a positive infinity. Now, why do I get to include the 2 this time? What about this question lets me include it? The equal to part, yeah, of the less than or equal to. That's why I get to include it. So that's all you do. It's just reading the graphs, just like we did on the other functions. So for this one, my translation point moves to -3, -2. So -3, -2. I am doubling my move, so I go 1, 2, and then 8, 4. And then this one will fit, but this one will not, so we know it goes off like that. And then you solve it the same way. Okay. Now let's talk about the way I like to solve, the algebraic way. So just like with every one of the functions we've studied, we're going to isolate our x, and this time our x will be trapped under a radical. It's either going to be trapped under a square root or it's going to be trapped under a cubed root. So basically I'm trying to get that radical part by itself. So that's going to be our step 1, to isolate the radical. And then we'll either square or cube both sides, depending on which radical we have. And then we'll solve what's left. Okay, so let's take a look at number 14. The first thing we do is get rid of our extra stuff. So we're going to have to add the 2 to both sides.
Haven't we already done this before?
We have solved a bunch of equations. We haven't done the square root and the cube root before, but we have done the square and the cube. So it's basically the opposite of that. Now the one thing that you do have to watch out for right here is, what if the square root of this ever equals a negative? Is that possible? No. So you'd have to notice, you'd have to be on the lookout for that. So if we had a square root equal to a negative, we'd have to say there are no solutions. So that's the one little thing you have to watch out for. But can a cubed root equal a negative?
Yes.
Yes. So just with the square root, that's one. Even roots we have to be careful of. So here we'll square both sides. And we get x equals 15. And it's the same process we've used for all the other functions. So, how about I do like number 20? This is very similar. So we would have to isolate the radical part. It is. It's almost the same. We'll divide by 3. Okay, and what do I have to do at this point?
Cube.
Cube it. And we don't have to be as careful with cubes because a cube root can equal a positive or a negative, so we don't have to be as aware. 4 cubed is 64, so when we subtract 10, we get x equals 54. Okay? And that's how you solve them algebraically, which I like a lot better. I would only do graphs if I already had to do a graph or something else. I would never use a graph to solve these equations. Okay guys, the rest of it's homework. Go ahead and use the next couple of minutes of class time to see how far you can get.